Welcome back. So here's another example regarding the separable differential equation. See, we have this problem, or we have this equation: 2z y plus 1 d of z is equal to y dy. And our initial condition is that when x is equal to 0, I mean when z is equal to 0, our y is equal to -2. Okay, so let's find the particular solution for this given differential equation. Okay, so first is to separate the variables. Separate variables. Then by doing that, we need to do some algebra here. Our 2z y plus 1 dz is equal to y dy. And in order for us to separate these z's to and y's, we need to, as you can see here, we need to divide the both sides by y plus 1. We're gonna divide this by y plus 1, and we're gonna divide this by y plus 1, and we can cancel this out. So we have 2z dz is equal to y dy all over y plus 1. Okay, and let's check. So all on the left hand side, we have all terms in terms of z, and for our right hand side, we have y's. Okay, so this equation is said separable equation. Okay, then the next step is to integrate both sides. So by doing that, we have the integral of 2z dz is equal to the integral of y dy all over y plus 1. Okay, so on our left hand side, this is a integrable by having z squared all over 2, so we can cancel this out. And for our right hand side, we need to do some modifications here, like for example using algebra. So let us try to let variable u is equal to this denominator y plus 1, and then our du is the derivative of this side, dy, and we can now substitute this term as u and this term as du. So we only have left with the variable y, and we can find the variable y here. So we have y is equal to u, transpose this plus 1 to the other side, so we have -1. So our y is equal to u minus 1. And by doing the substitution, algebraic substitution, so we have the value of y is u minus 1, and then our dy is just du all over this y plus 1 here is equal to u. So simplifying it further, we have the integral of u over u minus 1 over u du. And as you can see here, can now easily integrate both terms. So by the way, this u over u is just 1. So we have the integral of 1 du. So we have u minus the integral of 1 over u, which is equal to ln of absolute value of u. Then let's bring down this z squared. Then our plus c. Let's write our constant of integration on this side. Okay, and then to get the general solution, we need to bring back the value of u. So we have our u is y plus 1 minus ln of u plus c. So this is now our general solution. Or we can also try to combine this constant to our constant of integration. So we have y minus ln, I mean this is y plus 1. So we have y plus 1 plus c. Once again, you can express your general solution in terms of equation like this or solution like this, or you can also try to simplify it further by combining this constant 1 to our constant of integration. Okay, so this two general solution here is both acceptable. Okay, but our problem is to find the particular solution given the initial condition z is equal to 0 when y is equal to -2. So we need to substitute our third step. This is 1, 2, and our third step is to substitute our initial condition to our given general solution. So substitute initial condition to find the value of our constant of integration c. So once again, what is our general solution? So let's try this first. Z squared is equal to y plus 1 minus ln y plus 1 plus c. Okay, so we have our, let me rewrite it here. We have z squared is equal to y plus 1 minus ln of absolute value y plus 1, then our plus c. If we're gonna consider this as our general solution, then let's try now to substitute the value of our initial condition if when x is equal to 0, y is equal to -2. So I mean when z is equal to 0, y is equal to -2. So when z is equal to 0, so this is 0 squared or just 0, then y we have -2 plus 1 minus ln of -2 plus 1 plus c. Okay, so we have -2 plus 1, so we have -1 minus ln of absolute value of our -1 plus 1, we have -1 plus c. Then since this is absolute value, the ln of 1 is just 0, so we have 0 is equal to -1 plus c, or our c is equal to +1. And substituting the value of our constant of integration c to our general solution, we have z squared is equal to y plus 1 minus ln of y plus 1 plus the value of our c is 1. And as you can see here, we can now add all constant. So we have z squared is equal to y minus ln of y plus 1 plus 1 plus 1 is 2. So this is now our particular solution. Okay, so this is now our particular solution. Okay, so once again, for our third step, if we have the initial condition, then we need to substitute these values on our general solution to find the particular solution. Okay, so you can also try the our other general solution. Where is our other general solution? This one. You can also try this general solution if we will gonna come up with the same particular solution. Okay, so you may try substituting the value of your initial condition here, wherein our z is equal to 0 and y is equal to negative 2. Okay, and the particular of solution of both this expressed general solution must be the same. Okay, so you can try it on your own. So that's all for this video today, and see you on our next video.